So in this video, we're going to look at how to determine the length of a line segment. We're going to start by looking at an example. Determine the length of line segment AB, given that A is 7 and 5, and that B is 2 and 1. If I add these two lines to this picture, we see that we can use Pythagorean's theorem to determine the length of line segment AB. So let's call this side C, call this side A, and call this side B. Just by counting the squares, we see that side A is 5 units in length, side B is 4 units in length. So using Pythagorean's theorem, we know that C squared is equal to A squared plus B squared. So C squared is equal to 5 squared plus 4 squared, which is 25 plus 16, and 25 plus 16 is 41. But since we want to find the value of C, we are going to square root both sides, and we get that C is equal to the square root of 41. You can now use your calculator to approximate the answer, but leaving it as C equals the square root of 41 is also a valid answer. The square root of 41 is approximately 6.4 units. That is the exact answer, and here is an approximate answer. A better way to find the distance is to use a formula so we don't have to draw the line segment and then draw a triangle. So let's take a closer look at this picture. Let's start with the x values. If you look closely here, we can see that the length of this goes from 7 to 2. 7 minus 2. And you can see the 7 and 2 come from the x coordinates of the 2 points. So we call this, if you think of rise over run, this is our delta x. Similarly, if we look at this closely, this is delta y. And delta y takes the two y values, 5 and 1. So the delta y is equal to 5 minus 1, which gives us our 4. So there's our 4 units for our delta y, our 5 units for our delta x. So if you want to find the distance between 2 points, and we'll call the points x1, y1, and the other point x2, y2, then the distance formula, which instead of using c, we're going to use d, the distance formula is equal to, if we take the x2 minus the x1, that's our delta x squared, plus the y2 minus the y1, that's our delta y squared, and at the end we're going to square root it. Same thing we did right here. So that is one way to write the formula. Another way is to simply write it as the square root of delta x squared plus delta y squared. This is the distance formula for any 2 points on an xy plane. Let's now try to use this formula in example 2. So example 2, 2 airplanes are at 44 and negative 22 and 16 and negative 49. Which airplane is closest to the tracking center located at 5, 4? So let's give these some letters. So we'll call this plane A, plane B, and this will be our tracking center. We'll call it C. So if this is point C, the tracking center, then we can say this is plane A and this is plane B. This is just a rough sketch. And we want to find the distance from C to B and C to A, and we're going to try to find the distance. So let's find the distance from A to C. So I'm going to use a little notation here, say D, A to C. And now we know the distance formula is delta x squared plus delta y squared. Remember, delta x is the change in x's. The change in x is 44 to 5. So our delta x is 44 minus 5, and we're going to square that. Plus, we need the delta y's. The delta y is negative 22 and 4. So we're going to have negative 22 minus 4 and square that. So we do that, we get 44 minus 5. That's 39 squared. Plus negative 22 minus 4. That's negative 26 squared. So let's take a look at these two numbers. The biggest mistake that students make is that they type in negative 26 squared but don't put a bracket. Remember, this is negative 26 times negative 26. So if you use this formula, you're always going to end up with positive numbers in the end. So 39 squared is 1521, and 26 squared is 676. If we add these two up, we get 2,197. And we can stop there. You could approximate it if you wish. If you did that, you would get approximately 46.9 units. That's the distance from point A to point C. Now let's determine the distance from point B to point C. So distance from B to C. Again, the formula is delta x squared plus delta y squared. So let's take the delta x's. So this time we're doing 16 minus 5 for delta x. So 16 minus 5 squared plus, if we look at the delta y's, we have negative 49 minus 4, negative 49 minus 4. So 16 minus 5 is 11, and a negative 49 minus 4 is negative 53 squared. 11 squared is 121, and 53 squared is 2,809. If we add these two numbers up, we end up with 2,930 under the square root. And again, we could stop there, and we can already see that A to C is smaller than B to C. We get 54.1, so this is approximately 54.1 units. So therefore, plane A is closer to the tracking center. Last example. Calculate the shortest distance between point 65 and the line y equals 2x plus 3. So first, let's draw the line y equals 2x plus 3 and add the point 65 to our graph. So remember, 2x plus 3 means we start at the y-intercept of 3, and we have a rise over run of 2 over 1. So if we go up 2 over 1, there's a point, up 2 over 1, up 2 over 1. And if we want, we can go down 2 and to the left 1. And there is our line. So that's y equals 2x plus 3. Next, we have the point 65. So the point 65, we go over and up, is right here. What it wants to know is, what is the shortest distance between this line and this point? And to find that, we're going to need to find this distance right here. The shortest distance between a line and a point is measured from a perpendicular line from that point to the line. So this red line I've drawn here is perpendicular to the green line. And that would be the shortest distance from the point to that line. And you can see it looks like it hits this point right here. But we're going to verify that. Notice it has to be at 90 degrees, because here's one that's not at 90. That is definitely longer than the other one. And you can try drawing this and see where it would be the shortest. So the question is, how do I figure out if this is the correct point? So to do that, we're going to find the point of intersection of the green line with the red line. This means we need to find the equation of the red line using that point, 6, 5, and this equation y equals 2x plus 3. So let's try to find the equation of this red line. So we know it has to be y equals mx plus b. We actually know the slope of the red line. Since the green line and the red line are perpendicular, then the red line must have a negative reciprocal slope compared to the green line slope. So since m1 equals 2, that's from the first line, then we'll call this one the second slope, m2, is negative 1 over 2. That is the slope of the red line. So now we know that y equals negative 1/2 x plus b. So now we need a point to determine the y-intercept. Well, we know that point there. That's the point 6, 5. That's the point that was given. So let's use that point to find the y-intercept. So 5 equals negative 1/2 times 6 plus b. Remember, that is 6 over 1. So we get 5 equals 1 times 6 is 6. So we get negative 6 over 2 plus b. 5 equals negative 3 plus b. And b, if we move the 3 over by adding 3 to both sides, we get 8 is equal to b. So therefore, the red line is y equals negative 1/2 x plus 8. And if we look closely at the red line, if I was to extend that line, it looks like it's going to hit the y-intercept of 8. And it definitely has a negative slope. So this is the equation of that red line. Now we can see, where does that point intersect the green line? And once we find that point, we can find the distance from that point to the line. So, to find that point of intersection, we're going to take this equation here and our starting equation, y equals 2x plus 3, and we're going to solve for that point of intersection. We're going to use substitution. So let's call these a and b. So now let's actually try to find the point of intersection. So I'm going to sub a into b. And you could do b into a, it will still work out. If I sub a into b, I get negative 1/2 x plus 8 equals 2x plus 3. So I took this here and subbed it in for y here. We have fractions here, so the best way to deal with that is, let's multiply everything by 2 so we can get rid of the fraction. So I'm going to multiply this by 2, this by 2, this term by 2, and this term by 2. So what I end up with is negative 2 over 2, because remember this is 2 over 1, x plus 16 equals 4x plus 6. Negative 2 over 2, that's going to give me negative x, plus 16 equals 4x plus 6. And if I rearrange this equation, let's bring the 4x to the left, we get negative 5x, and the 16 to the other side, we get minus 10. Divide both sides by negative 5, and we get x is equal to 2. Now let's keep going. We're going to sub x equals 2. We can sub it into a or b, so I am just going to pick b, because I don't have to deal with any fractions. So I get y equals 2 times 2 plus 3. And that gives us 4 plus 3, which is 7. So therefore, xy equals 2, 7. Let's go to the graph and check that out. If I go over here, if I count 2 to the right and 7 up, it hits that point right there, just where we thought it would be. So now we have 2 points. Let's call that point B. Let's call this point A. Let's find the distance from A to B, the shortest distance from the point to the line. So we have A, which is 6 and 5, and now we know B is 2 and 7. So if we want to find that distance, we'll call the distance of AB, it is the square root of delta x squared plus delta y squared. And if we go through that, delta x would be 6 minus 2 all squared plus 5 minus 7 squared, and that would be equal to 8 squared plus negative 2 squared. And again, if we square both those numbers, that's 64 plus 4, which gives us the square root of 68. So the distance from the point to that line, the shortest distance, is 68 units. So if I want to calculate the shortest distance between a point and a line, remember that it's measured on a perpendicular line from the point to the line. So that means I need to find the equation of this line here. And once I find that equation, I can find the point of intersection of those two lines, the perpendicular line and the given line. And once I know the point of intersection, I have 2 points. And with those 2 points, I can find the distance using the distance formula. So here are the questions you should try, and good luck.